Hey guys, today we're going to do some more factoring, but special cases is what I call this. So we're going to use some polynomial identities to help us factor. Some of these you'll memorize right off the bat, like difference of squares, but some of these harder to recognize that you might want a normal factor. Okay, so here's the idea about factoring. Factoring is starting with the right side, matching it to its polynomial identity, and then coming out with the left side, okay? So remember that when we did this before multiplying, you identify what identity to be used, identify the A and the B, substitute, and simplify, okay? So on example 1 here, we have 4x squared plus 9. So one of the things I want you to keep in mind here is it's a plus. And then the other thing you need to keep in mind is that when we are looking at the right side of those identities, it also means that our A and our B are squared or cubed, right? Because it's A squared, B squared, all that stuff. So how I identify usually is I say, okay, I'm looking for two terms here with addition in the middle. So if I look at all my right sides here with two terms with addition in the middle, I have these two right here. Now 4 and 9, are they a cubic or a square root? Or square, I mean, it would be a square, right? So we're actually doing the sum of squares. Okay, so really when I look at this, this is A squared plus B squared. So when it comes out, it's supposed to be A plus BI times A minus BI. Okay, now keep in mind when we identify A and B here, we need to take the square root because these are squared, right? So we have to think about this as, and I'm going to put it on the side here because I didn't leave myself room. 4x squared is actually 2x squared plus 9 squared is 3. You're writing what I'm saying, huh? Okay, so that means my A is 2x and my B is 3. Okay, so when I substitute in, my answer is 2x plus 3i times 2x minus 3i. Okay, and we're done. That one's a little bit easier, right? Okay, for B here, we have two terms that are added together, okay? So I go back up here and I have my two terms. Now I look at my numbers. Technically, I can look at my variable and that tells me if it's squared or cubed, right? Our x here is cubed, so I know that I'm dealing with the sum of cubes, okay? So when I deal with the sum of cubes, that means my resulting on the left comes out to A plus B times A squared minus AB plus B squared. Okay, I'm actually going to write this work underneath, unlike I did up here. So I know when I have my A and B, I have to keep in mind that this is cubed already, so I have to cube root it. Well, what's the cube root of 27x cubed? It would be 3x, and then all of that is cubed, right? What is 64 cubed or cube rooted, right? 64, that would be 4 cubed. Now I'm definitely able to identify that sum of cubes. So my A value is 3x and my B value is 4. Okay, so if I substitute in, I get 3x plus 4. It's early in the morning, guys. And then I substitute in, I get 3x. All of that is squared minus 3x times 4, because that's our B there, plus b squared. Now, of course, I want to simplify that more if I can. Simplify means that in that binomial or in that trinomial right there, I'm actually gonna square things and multiply them, okay? So this is 9x squared minus 12x plus 16, okay? Very good. Let's try a couple more, okay? So right here, sorry, I have some calc stuff underneath. Right here, it's harder to see, right? I have this 9x squared minus 12xy plus 4y squared. So one thing I keep in mind is I'm dealing with three terms. I see that it goes minus plus. So let me look at my three terms. So on this side, we all have two terms. Here's four terms, so it must be up here. And what do you know? There's your minus plus. So it's a perfect squared trinomial, okay? So my answer should come out to be a minus b squared. Now, here's my trick. If you want to prove it to yourself, you can definitely identify your a and b. But if you know you're correct, just do your two ends. So remember that 9x squared is 3x squared, right? Because we're identifying a and b. And on the outside here, this would be 2y squared. Again, if you want to prove it to yourself, remember that inside term should be negative 2 times our a times our b. I'm not giving myself some room. I'm sorry, guys. And what do you know? Negative 2 times 3 times 2 is negative 12. So we know we're working out really well here. So a in this case is 3x. B is 2y. So when I substitute that back in, I get this 3x minus 2y squared, and I'm done. Okay. For D, I have four terms and it goes minus, plus, minus. So our four terms on the right side here is down here, the cubic polynomials. And remember, it goes minus, plus, right? So that means it's the A minus B cubed. Now I'm going to do it faster. Right here, I proved to you and see why it works, but I'm going to do it faster. I know this works in this case because of what's happening in here, and I trust that I'm doing special cases, right? So all I'm going to do is identify my A, which, okay, I have to take the cube root, right, because it's cubed. So that would be 2x for my A. And my B, well, the cube root of 125 is 5. So that's my A, and that's my B. So right away I can go 2x minus 5 cubed. Keep in mind that all polynomials that have four terms and the last two terms that are perfect cubes doesn't mean this is going to be a cubic identity or cubic polynomial, for the fact that these might not come out to where they're supposed to be. Some might not be factorable. But right now I'm focusing on how to do the identities, okay? Now, of course, if we get something like this, there's no real pattern. If I go back here and I look at my trinomial, so my three term right there, I don't see that 6 is the perfect square, right? So I know that doesn't work. So I have to go back to, hey, my old box method or whatever you chose to factor with. So I'm asking myself, 1 times 6 is 6. What two numbers do you multiply to give you 6 but add to give you 5? Right? So that's 3 and 2. And then I can do my grouping. So x squared plus 3x plus 2x plus 6. Group. Let's see, we have a common term of x. So that's x plus 3 there. Common term of 2. So we get x plus 3 here. And what do you know? That means my final answer is x plus 2 times x plus 3. Okay. All right, let's do some practice on their